So my name is Alex Amaya, Technical Marketing, and I'm here to actually give you some live demos. We actually have product right here sitting right over to my left, right? So I'll talk about the torture test that we built in-house. It's kind of like our own sophisticated, very complicated, configuration, which I was able to put on the table right here. And that torture test really had an objective, which was really measure loss. How do we deal with loss when we start talking about some of the business intent policies that we talked about, right? So we create an overlay, we have these underlays, but when you inject loss, what really happens, right? So what we did is we took one of the policies, which was the high availability, which is like, to me, the top of the cream, right? Which is something happens, fill over to the next, we got 50-50, bandwidth being used, got error correction, it's path conditioning, it's everything in there, right? And we took it to the extreme. We gave it, 100% loss on the link, 5% loss all the way across, 30, 40. And what I'm going to show you is give you a couple examples what really happens when you actually start seeing live view and injecting and seeing how we interpret some of these brownouts, right, as we go through. And then I'll bring in Unity Boost into the mix and be able to show you a quick demo on how we address some of this latency issues, not only latency mitigation, but data reduction, right? So the torture test that I'm going to do here for you guys really quick is going to give you two scenarios. I'm going to actually inject 5% packet loss on all of the links, and then actually I'm going to have live view, not live wire. I was thinking about the mountain bike track here. But live view, 5% packet loss, and then explain to you what's really going on. We're actually going to see the actual data coming across and instantaneously notify you there's been a brownout. Now the second scenario is going to make it a little bit more interesting, which is going to give you like this data reduction, like what you see, 30% loss on broadband, very minimal interaction on the MPLS side. And then for fun, we're going to throw in some video stuff for you guys as well too. And the last one, I'm going to start bringing in some latency testing, but I'm going to do it through the Unity Orchestrator. I don't have to jump around with many. I could use one overlay and be able to accomplish this within that infrastructure, right? So a lot of the stuff that was just discussed, we're just going to quickly show you here. What does the network layout consist of? Very simple. We got our EdgeConnect appliances. We have some virtual emulators. These are open source that we configured here. And then we have our two clients left and right. And that's what you see over here right next to Greg. We have, clients is running iPerf3 back and forth between them. And then we got our EdgeConnect appliances. And we got just a generic, switch that we're running across this. And I'm going to actually manage it through my orchestrator. Pretty simple off of that. On the congestion side, I'm going to actually just show you that I'm going to run 30% loss. Actually, these are 15, but it's going to be aggregate 30% and a minimal loss on the top. And you'll be able to see that through live view. If you look at the scale on live view, we're going to be able to show you what you're actually seeing, right? And I think Damon and Rolf kind of explained a little bit about what live view is about. I'm going to actually bring up the true test case as we're seeing here. And the boost performance is actually just moving data across from one to the other. So with that, let me get it right into our demo. And this is Orchestrator, right? And I currently have those two appliances set up right over here. Let me know if it's too small for us. I'll try to. And my overlay is my data, and I'm actually going to just dive right in. I already have some data moving across in here. And it's actually a video feed coming one way, UDP, iPerf traffic going the other way. So it's asymmetrical data as I'm moving across, so about 50 megs or so of data. And what I brought up is actually the loss also, right? So you guys can see there's currently no loss. It's just clean line. Our overlay up at the very top, our virtual overlay is giving you, the just a little bit over 5 or so megs. And this is actually showing you from the appliance to the right, and it's on the inbound. So now I'm going to start interjecting some loss in here. And right away, we're going to start recognizing this loss. So instead, I'm going to put 5% loss. On my overlay on my data, I've actually added 1% as my brownout threshold condition, right? So we should really be able to see right off the bat, we're starting to see this loss to come in, right? So I'm going to put it on the secondary link on my MPLS. And I'm going to add it to the other one. So upstream and downstream, we got loss going both ways here.
Possible to embiggen a small amount?
Make it bigger?
Yeah, just, Command plus or whatever it is you do on Windows.
Actually, let me see if I can do it this way.
Perfect.
There we
That's,
go.
Yep.
Yay.
Yep.
Mold.
So basically what you're seeing here is you're actually seeing our bandwidth, our overlay, right? So to the customer, they're seeing just the data coming across, But to the network administrator, it's like, okay, what's going on here, right? What's really happening?
Time to beat up the vendor.
Time to, yeah.
Beat up
We're
the
actually
carrot.
are now able to go and see and measure the jitter, the loss, right? The latency associated to this. But in this test, we actually were just measuring the loss is what we're focusing on. So with the HA policy, we're actually being able to see that as the customer comes in and he's using the application, there is really enough of an issue that's happening to him. But there is something behind the scenes, right, that we got to go and address. Where is that coming from? So this is live and instant, right? So this is 5% going upstream, going down, and back again. So right now I have video and I have UDP traffic going both ways asymmetrically, right, on this one. And we just pumped it to like 35 megs on one area. Now the video we're going to get to in the cool piece, right? So I'm going to bring it down to MPLS having really minimal, which is more on the realistic side, and maybe we got a 30% congestion, right? Something that at night Netflix kicks in and all these hotels, and all of a sudden your broadband's just starting to get the congestion, but MPLS is just sitting kind of idle out there, right? What happens in a scenario like that? So what we have right now here, I'm going to go into the broadband. Actually, I'm going to bring down the MPLS. And we'll put it like at 0.20, something very minimal on the MPLS link. Now the MPLS link will start coming down. It should go from that brownout condition to the green. And I'm going to go over into my broadband here, and I'm going to bring this up here. So it's going to get a little bit crazy here because this is going to get pretty high here, 30%. And I'll go number 2. So the traffic here should start adjusting here. The path conditioning start coming into effect.
How frequently is it polling?
This one, we're pulling what, every second?
Yeah.
Just about every second?
Yeah, we're making those decisions on a second-by-second basis.
Second by second, yeah.
I think part of the reason you might be asking the question is, why is the MPLS still brown?
Still brown.
And so we react immediately to increased loss when we color code the charts, but we wait for a 60-second rolling average before we take it back out, back down to the green.
case it
So
goes up and
you
down.
saw the loss go immediately from the 5% that Alex had it down to the 0. You saw the chart go down. The color coding will take about 60 seconds before it goes back to green.
Right. As you can see, if you look at the data still within the loss and the customer, we're still handling that data. Our path conditioning here has kicked in this case as well. Now we'll make it a little bit interesting. Here's a little something for you guys. Greg, I'll probably ask you to help me out here on this one real quick, right?
I can unplug cables like no one.
Exactly.
Yep.
I think that's your favorite.
The mark of a true engineer.
I'm a chaos monkey.
In more ways than one.
Reboot in.
Wave at the camera.
Hi. Where am I? I don't even see myself. I'm there.
Hi, Mom, I'm on TV.
It's probably for the best.
So what we'll do, Greg, is pull the broadband. We still have that issue with the broadband right now, which is 50. The broadband is this guy right here on the top. Just pull that one out and flip it. Now, as we were talking about measuring this, we should see the link all of a sudden here go down.
Oh, no.
I'll do it. Someone show it that it's working.
Gotta do something, guys. But now you'll see that we've responded to this condition, right? We were notified. Our MPLS now came in and said, okay, this is the condition that we know. Now we have one link, right, that we're active here. So the configuration on this, it's a virtual overlay called data, right? But I'm actually creating what we call a primary bond, right? I've actually taken a broadband and an MPLS and combined them together and then put them into this HA policy, right? So that way I can send traffic across too. But in this condition right now, I've lost completely one. Now I have just my MPLS link at this case. So we're measuring still that, hey, I could still send that traffic because that jitter, that latency, and the actual loss are not hitting that threshold, right? So I'm actually able to use this.
So what?
Go
It's cool. It's really cool that you unplugged it, but on our MPLS we get a lot of link flapping from wherever because we have branch offices in the middle of nowhere. So what happens when the link's going up and down every 2 seconds or BGP's flapping every second?
So we should be able to see that and capture that data, right? We should actually be able to notify you as it's flapping. You're probably going to get flapping where it's off completely. You're going to get red, that it's showing you that you actually have that condition going on to that extreme. I mean, if that is the case, I mean, that's something you really need to go and.
But can you decide fast enough when it's going between a upstate and a downstate to properly redirect that traffic?
We should, yes. On the HA policy, yes.
Yeah.
Yes.
So I get the idea is that you guys can reduce the effect of the outage or the brownout because you can shift the traffic, but can you also help identify where the actual problem is and what's going on? Can you do any kind of identification, root cause, troubleshooting?
Yeah, we can. So obviously, it's the live view chart right now is showing you which link is having the brownout condition or the complete blackout condition. We also have a bunch of additional tools built in. For example, from live view, you can initiate a trace route right there, and you can see hop by hop where's the loss or hop by hop where's the latency. So those kind of tools are there. And obviously, we've got things like TCP dump and everything else built in as well. But that's a really important thing. It's kind of like when Rolf showed you guys earlier the health dashboard. You know, real-time troubleshooting is one thing, but also going back historically and figuring out which link had a problem is really important as well. Yeah.
And can you report that out? So if, like, to Eric's point, if he's seeing MPLS flapping, he wants to go to the provider and say, hey, what the heck, and here's my proof that this happened.
Maybe email them and take care of the entire.
Well, we're not going to email him for you, but to your point, like every single metric you see that's in these charts, you can set a threshold for and get an email if it crosses that threshold, either above it or below it. You can have that be an SNMP trap. You can have that exported in a CSV file to show to your vendor. It's all available via REST APIs. So we have some customers that, even though they like our charts, they want to build a custom chart, right? And they'll use our REST APIs, and they'll show that in their NOC. So, and then it's all stored on the appliances and also stored in the orchestrator for historical reporting periods. So, yeah.
Great.
So on the last piece, we're talking about the our Unity Boost, right? And in the Unity Boost here, we're going to deal a little bit with latency. So I went ahead and added some latency into our broadband. So with Unity Boost, obviously, we want to deal with data reduction, where we actually are able to create that application performance, and then you're looking at the latency mitigation, right? Where we want to give that user that experience, the positive experience, right? They're just not waiting for something to happen. So we could do this with our business overlays. I think Rolf and Damon were mentioning this earlier in the presentations. So we can actually add Boost onto the actual overlays you create as you need it. So what I'm going to do here is actually jump off into one of these systems here to my left on the table. I just wanted to show you that latency has been added to the broadband, and there's still some loss in there. And what I'm going to do is actually, I'm going to open this up a little bit bigger here. You guys are still happy? Yeah. I'm going to actually bring my timer here, and we're going to move a file. It's like a 40 meg file. And currently now there's no boost on this overlay on my data, and we should be able to see some, so notice we got some pretty good pipes here. We've copied a bunch of these files already, so I started a little bit late. We're doing about 6, 5 megs or so. So now I'm going to go into, so let's say 7 seconds. I'm going to go into my orchestrator here, add boost. Into my business overlay here. Down at the bare bottom, so we had to make this a little bit bigger. Save this. Now, as you know, we could actually, since we talked about, okay, here's the business template, we can secure it, we can redirect the traffic, right? But a lot of times you're thinking about, well, what about enhancing that performance on that application? Can you do that? So that's what I'm going to try to show you. Yes, we can, right? So if you guys heard, we could do WAN-op, right? Can we bring that in? So without me going into a different application, I've actually just done it right now. It's as simple as that. So our Unity Boost is a separate package that you'd have to buy license space to it. So it'll go off, and you saw that it's been doing some sort of synchronization. It wants to make sure you're licensed for that, right? And you go ahead and you apply it. So as I go back and then I move that particular file again that I just moved over, wow. So I did it a little bit quicker. I was trying to get to it. Try it again. But you get the gist out of this here, right? So I'm going to say copy, stop, reset, but it's already there, right? Yeah. It's a 40 meg file that it knows, we've done this before. It has this up, like Rolf was mentioning, the timestamp's already there. We know you passed this information over. You don't really have to deal with that wait time, that latency issue. But what's really unique is that now we've actually have everything in one, right? It's that orchestration with the EdgeConnect appliances that you don't have to go with multiple appliances out there to bring this in. Is that cool?
Yeah.
Is it Kool-Aid time?
It is.
I think that goes back to Greg's point, right? With SD-WAN and all this additional bandwidth, is that the death knell for WAN-opt? Well, it's got all this additional bandwidth, but some applications still need it. So.
Yeah, my question is, the ROI equations become different.
That's
where
exactly
before your WAN accelerators worked for certain, high-priced MPLS circuits with strictly limited bandwidth. Well, all of a sudden, if you can go from a 10 meg MPLS to a 100 meg internet connection, the ROI calculations change. Right. So now that doesn't mean that there's not use cases like cruise liners and mining in Uzbekistan and any other number of corner conditions that are exactly that, corner conditions. They're unique, very small percentage of the market, and WAN-op will continue to occupy those. And even for specific use cases, you might have an application where you want to transfer very large files at very specific conditions, like graphics, like AutoCAD files, or the movie studios who are transferring, 4 terabytes of video overnight. But WAN acceleration is going to make a difference, right? But for your average person who's using WAN-op, you might just be able to say, go from 10 megs to 100 megs, I don't need WAN-op anymore, but it's ready for the future when I do. Because when I suck up all that bandwidth, I've got still, these solutions that come from companies who have the WAN optimization. There's two things. One, I've got the option to just cough up some money for a substantially, reassuringly expensive license, or I can, the second thing that I get, and the advantage I get every day, is that you're using your WAN-op experience to optimize the flow of packets anyway, right? So your 12 years of experience in building WAN optimizers built into this product already, right? Your ability to do single packet recognition, application flows, tunnel encapsulation, all those features that you've got, they're all in the product now. So in that sense, the WAN-op SD-WAN players are very different from the routing-centric SD-WAN players. And there's a fairly, people, as they evaluate you, they should understand that difference fairly. It should come out anyway. So that's why I'm saying ROI for WAN-op is changed and is generally of dubious value would be my starting position. Does that make sense?
I think it makes absolute sense. And in fact, I don't think I could have phrased it any better. And part of it is when you look at the way WAN-opt products were traditionally priced, there's a price point at 2 meg and 4 meg and 10 meg, and it follows the MPLS pricing curve, and you pay more as the bandwidth goes up. And when we looked at SD-WAN, we said, well, this doesn't make any sense. If I'm using a 100 meg internet connection, I can't possibly pay for a 100 meg WAN optimization device. The economics.
As if it's like a 100 meg MPLS circuit, because before I was paying
exactly
50,000 a month for a 100 meg MPLS. but now I'm paying $500 a month for a 100 meg internet connection.
That's right. The economics are just completely blown out of proportion. So when we introduced the SD-WAN product line, and I didn't really go through that in detail, I talked about the hardware appliances and the software license. The software license for SD-WAN EdgeConnect is something that's per site based, independent of bandwidth, up to a certain amount, and then there's another license after that. But that's where the value is. The value in SD-WAN is in connecting the sites. So that's how the product is priced. Now, if you do need additional WAN up for some of the cases you mentioned, then yes, there's an additional license where you can add Boost on a per site or per application or whatever you need it basis for those cases where you need it. So it's, the economics are so radically different, it's a completely different pricing model
Yes.
to address that.
That's very important for you.
Yes.
And I've got a specific follow-up
And our
question
customers.
to a point that Greg made yesterday, because we talked about this previously in SD-WAN, and that was about we're getting into this cloud world, we get into AWS, and we've returned to a land of metered bandwidth and paying for bandwidth. So one of the questions that was raised is, WAN app maybe have the potential to, help reduce the cost of metered bandwidth in the cloud, but at the same time, WAN app's computationally expensive. Do you see that as a complete wash in the cloud of the cost of, paying for CPU versus WAN app, or is that a, scenario you guys have even dug into for the economics of it?
Yeah, I think the real value to the customers of deploying SD-WAN in the cloud is about the connectivity to the cloud. Making that AWS implementation part of their SD-WAN.
Right.
I don't really think many people are looking at the trade-off of, yeah, if I dedupe the data, then I don't have to pay as much to extract it from the cloud. I don't think that's a real big part of the customer's economic equation.
Okay.
Yeah.
Curious.
Yeah. It's valid, but I just don't think that they're.
It was just a question that came up. We were discussing. Would that have any potential benefit? Would that be a thing?
Yeah, it does, but
Yeah.
I think it's sort of to the right of the decimal point for most customers
Yeah.
when they're looking.
You may
at
not
that.
be paying for the CPU either.
No, I don't have to pay for this. I don't care about the CPU.
Yeah,
No,
so if you're
design
in the
solution.
cloud and then you're burning
Yeah,
the
we
CPU.
just build the
As long
widgets.
as the network
Somebody else
budget's down and the
pays for the
server
widget.
budget's up, that's a win.
That's right.
Yeah, who cares?
You're building it. Somebody already.
I want to ask a somewhat leading question because I got to see your presentation at NFD 11. And one of the things that most impressed me was the way you handled loss on multiple links. And I don't think it's something we've actually really talked about or how that works. So I don't know if you guys can at least highlight it.
Yeah. So I'll talk about it the same way I talked about it there. So, and yes, we did sort of gloss over it today, but the way we handle loss in general is something called FAC, forward error correction. It's similar to, if you guys are familiar with DWDM, forward error correction there, or if you're familiar to how the RAID vendors do parity striping on disk drives, it's a similar concept, which is if I send redundant information, I can recreate anything that's lost. So in the very simple example of, let's just look at one link. Let's say I send 10 packets of real data. I'm going to append an 11th packet, which is a parity packet for all that data. And then I'm going to ship over all 11 packets from point A to point B. If I lose any one of those packets, I can recreate it from the additional redundant data I have. Just like if you pull a drive out of a RAID array and stick a new one in, it can recreate it from the redundant parity data it has. Now, in the actual implementation, it's not necessarily 1 for 10. It's more like 4 for 40 and other higher multiplications depending on how we're configuring it. And we also do it in real time. We adjust the ratio of error correcting packets to data packets depending on how much loss we see. So you're not always paying that penalty of additional information. So that's in the single link case. In the multi-link case, depending on the policy that you chose, when we showed you those high availability, high quality, high throughput policies, it will depend how we distribute the packets. In the case that's sort of the most interesting, it's that high availability case, the case that you would use for something like voice. And what we actually do there is send all the data packets on one link and all the error correcting packets on the other link, whatever the backup link is. And at first blush, you might think, well, that's similar to other schemes that send a copy of the data on the other link, but it's much more powerful because if I'm sending a copy of the data on the second link and I lose packet 5 on both, I've lost packet 5. But if you're sending the real data on the first link and parity packets on the second, you can lose up to any 50% of the packets and recover the whole stream. And that's kind of how the scheme works.
That's really interesting.
I appreciate the leading question. I love it.
I'm just curious, did that come out of the IP video world? Because I've seen some similar algorithms come out of the broadcast IP video world when you're having to do live streaming, that kind of a parity bit.
Yeah.
scenario. I'm just curious if there were any
It
roots
didn't
there.
really come from that. I mean, it really goes back to sort of our WANOps heritage. That's something that we built into the product for day one. I mean, we'll go back many, many years when we were talking to customers, and this was, again, WANOps days before SD-WAN, and we were trying to encourage people to leverage the internet instead of MPLS for things like replication. And that's where we started to build that technology. That along with packet order correction, where we can correct for out of order packets, because anytime you're using multiple links, the latency varies, and you got to correct for that too.
Sure, yeah.
And it's something we've built up over time and just continued to strengthen and become a core.
This is what I mean about
set of our
WAN-hop.
value prop.
When you look at SD-WAN providers who come with a WAN-hop heritage, this is what they do. Whereas if you look at SD-WAN providers who come from a routing heritage, they're like clapping their hands together when they get 2 links to load balance. You know?
Yeah.
It's a very different perspective. Yeah.
I think someone behind you is going to be using that quote. I'm just, I find that this idea of being able to detect, what you've called and what others call brownout detect, events, work around them, move traffic to another link, even in environments that would traditionally fail a routing protocol, right? Because that's our barrier now, unless we start using SLA or PBR or other,
That's right.
other mechanisms. Right now, we have to have enough loss on a link for a neighborship to fail before we start really using a backup link. And in this case, with more intelligence about the link, actual performance, we're able to move to a link that may be better. And then if both links are failing, if you have a multi-link setup, being able to send parity packets and the idea of, okay, well, I might lose 10 packets on this link and 10 packets on this link, but the chance of both of them losing the packets that require me to not be able to rebuild my data on the other side is just infinitesimally small.
Exactly.
It's just something we can't do now, right? And so I just think it's a compelling argument.
I really appreciate that. And really, the other thing too, it's core to the concept of being able to leverage the internet, right? I mean, the MPLS is reliable. It has very little packet loss. It's up a lot of the time.
Wow.
Well, some people would argue otherwise,
Fair
but
enough,
we'll
yeah.
take
We'll
that
go with
as
that,
we'll take that as a tenet. But if you go and add internet, yeah, you're getting 100 megs of bandwidth at a tenth of the cost, but it is going to have brownouts. It isn't going to be always reliable. So you can solve that problem a couple of ways. One is, pair your MPLS with internet. Another is to do what we do with forward error correction and packet order correction to make that internet have a higher real-time reliability than the actual packet loss is happening.
Right.
And the other way is to bond the two internet links together, right? Because now the chances of you having a brownout on both links at the same time is infinitesimal. And now you can really go, well, maybe I can use 2 internet links or internet plus 4G LTE.
Or reduce your MPLS to just
reduce
those
your
things that are
MPLS
absolutely
to
critical and
just what
use
you
2
care about.
internet links otherwise, because the amount
That's
you
right.
save in MPLS bandwidth, I can buy 2 internet links at the same
Exactly.
speed or even higher capacity from a throughput perspective as what I was getting before through MPLS.
Exactly.
Cool. And I think with that, we want to show you a quick video from one of our customers. I think you guys are Mustang lovers.
When you start a 427 Cobra engine, it's a thrill that you don't get from any other car.
How do I know? My name's Carol Shelby, and performance is my business.
Carroll was a 50,000-foot guy. So when he tells us he wants to create a car with 1,000 horsepower to the rear wheels, he just expects that to happen. Car design back in the 60s meant everything was hand-drawn. But today, of course, everything is very different. Everything is CAD. Everything is rendered and tested and thought through before it ever is made into a part. Just like any other business, we run office applications, but we have custom programs that run on our network to manage manufacturing, an online store, shipping that goes with the online store. We have a lot of different aspects to our network that many companies don't have. We decided to take our servers and the security threat that having servers on premise could pose and put them in a data center. It's important to me that the applications on our network function at a high speed. MPLS was just far too expensive. Thinking about SD-WAN solutions, we talked to a couple different vendors. The Silver Peak solution was the best solution. Without SD-WAN, we wouldn't be able to have people's documents housed on servers that are off premises. Through the use of Silver Peak Unity EdgeConnect, we were able to get that speed up where the users didn't even notice. We were able to make a 50 meg connection appear to be 500 megs. One of the most important aspects of my morning routine is going into Orchestrator and looking at how my SD-WAN is performing. We see a savings of around $1,500 a month. Network speed and security are both extremely important to Shelby American. And we can't have any downtime, just like you can't have a part fail on a car. We can't have a part fail on our network either. I need performance. My users need performance. It's a foundation that this company is built on. And the SD-WAN solution that we found through Silver Peak was a rock-solid performer for us.
And with that, we thank you guys for your time.
Thank you.
Take care.
Thank you.